Okay guys, in this video we're going to cover Unit 2.5 about deductive reasoning. And here's a definition. Make sure that you pause the video and copy down the definition, then return to the video. And the definition is that the process of reasoning logically and drawing a conclusion from given facts and statements. So that is the definition of deductive reasoning. So deductive reasoning is probably most frequently used in math and science researches. I'm going to sort of sidetrack a little bit. If you recall, in the last unit, we introduced the concept of inductive reasoning, and here we have deductive reasoning. And you may be wondering which is which, what is the difference? So recall when we talked about inductive reasoning, we started with lots of data, lots of evidences. And then from these data and evidences, we draw a conclusion. And that conclusion can be applied rather generally. So that process, starting from very specific data, is called, so this part starts from data, evidence, research, and then you go and draw the conclusion. That process is called inductive reasoning, right? So in class I probably talked about the CSI. The detectives have to collect evidences first before they can prove somebody is guilty. You can't assume somebody is guilty and then collect evidences. You cannot assume somebody who's guilty without good reason. So you really have to look at the data, look at the crime scene, collect your information first. Deductive reasoning is often done in math and science, in any kind of science labs, in fact. And you generally have a theory, but you have to prove that theory. How do you prove that theory? And one way to prove it is to experiment with it and then collect data and then verify the pattern and then redraw that conclusion. So it starts with the general principle and then reaches down to the evidences and whatnot. Okay? So here's some funny cartoons about this. And if you look at this guy, obviously he is daydreaming about a girl here and on top here, right? And then he is at night, he's still thinking about this girl here. And when he's eating, he's thinking about the girl here. And I actually don't know what that means. When he's in the classroom, hopefully he's not in my classroom. And when he's on the computer, it looks like he's still thinking about the girl. So we've collected all of this evidence, and then we draw the conclusion that he probably loved her. That's our conclusion. He probably loves her. So that conclusion is drawn based on our observations, all these data we collected. That is, my friend, oops. How do I get rid of this? There we go. So that is an inductive reasoning process because we started from the observations first. Here we have a statement. All cats have 4 legs, right? Then I have 4 legs, therefore I'm a cat. So I started from a statement, I started from a conjecture, I ended up with another conclusion here. So I started with a statement or a theory or a principle, and then I went and collected data, observation, research, so on and so forth. And then I draw the conclusion that this dog is actually a cat, right? It's not a correct conclusion, but you see that the important thing is that we started out with a statement up on top. So that, in this case, this is called deductive reasoning because you derived a theory and proved a theory. So it's deductive reasoning process. Okay, here again, this slide illustrates the differences between inductive reasoning and deductive reasoning. Okay, law of detachment. Law of detachment says given a conditional statement, if the hypothesis is true, then the conclusion is also true. And the way we write it is if P, then Q, that's a conditional statement. P is true. Notice these 3 dots means therefore. I will notate on the side. 3 dots is symbol for therefore. Okay? So now let's look at some examples. I have number 1. Given if Mark saves $30, then he can buy a new game video. So if P, then Q. So that's my 2 statements there, and that's my conditional statement with the if there. And now Mark saves $30, so my hypothesis is true. Then my conclusion is simply the second half of it, where the Q is Mark can buy a new video game. Right? Second one, if a quadrilateral is a rhombus, then it is also a parallelogram. Quadrilateral ABCD is a rhombus, so this matches the P. So then I can say then quadrilateral ABCD is also quadrilateral ABCD is also a parallelogram. Okay. Number 3, if you are 18 years old, then you can register to vote. So if P, then Q. Notice here, what's given is Olivia is not 18 years old. And let's look back in our original statement here. It doesn't say anything about negation of P, right? So it only says that if P is true, then Q is true. So in this case, we cannot draw any conclusions. It doesn't say what happens to kids who are not 18 years old. So we say no valid conclusion. Okay. Let's see. Let's look at number 5 here at the bottom. If you plan to attend prom, then you must purchase a ticket. So there's my P and there's my Q. If P, then Q. Sarah purchases a prom ticket. So, but this is saying that Q is true, right? So our symbol is if P, then Q. P is true, therefore Q is true. But in this case, I'm going to use a red one. It says that rather than P, I have if P, then Q. But Q is true. It doesn't say anything. Therefore, the answer is no valid conclusion. Okay? So you see that logical reasoning is very strict. It has to be step by step. It really limits the way you argue, but it also makes the way you argue very tight, very airtight. All right, let's look at another law. This is the last one. Law of syllogism. In certain ways that this is actually easier. So let's look at this. Law of syllogism allows you to draw a conclusion from 2 conditional statements in which the conclusion of the first statement is the hypothesis of the second statement. So if we use a symbolic map, we say if P, then Q. That's the first conditional statement, right? The two conditional statements. Then the second conditional statement is if Q, then R. Also notice the conclusion of the first statement is the hypothesis of the second statement. Then I can say if P, then R. A simple example is if I'm taller than my sister is taller than my brother, then I can say I am taller than my brother, right? So let's look at some specific examples. It says that if it is Saturday, then Jake has a baseball tournament. If Jake has a baseball tournament, then he will need to pack his lunch. So the conclusion here is I have my P, then I have my Q. Notice my Q again. Then I have my R. So 3 statements, but 2 conditional statements. So my conclusion is if P, then R. If it's Saturday, then Jake, I can say he, but it's clearer if I say Jake will need to pack his lunch. Okay. I think I'm okay with the next one. You should be able to do number 8 as well. Number 9, let's see. If it is sunny this weekend, then you will go boating. If it is sunny this weekend, then you will wear pants. So I have if P, then Q. And then if P again, then R. So it doesn't fit my symbolic map, right? So in this case, I would say no valid conclusion because it just doesn't make sense. There's no connection between these 3 statements. No valid conclusion. Let's look at number 10. If you shop at Target, so that's my P, then you will use your Target red card. That's my Q. And if you do not use your Target red card, this is a not Q, then you will not get 5% off. So that's an R, or not R if you will. So again, it doesn't fit into my symbolic map where I have if P then Q, because I have P and if Q then R, then I can have if P then R, right? So it doesn't fit that because this Q, the second, the conclusion in the first statement, as well as the hypotheses in the second statement, do not match. They're not the same thing. So therefore, the answer to this one is also no valid conclusion. Doesn't meet the criteria in this symbolic map on the right. So let's look at number 11. If it snows, then schools will be canceled. If school is canceled, then students will need to make up a day of school. So if snows is my P, then school will be canceled. It's my Q. Then I have if school is canceled, here's my Q. Then I have a third statement. So in a way, this is easier. We just need to say if it snows, if P, then students will need to make up a day of school. Okay, so this is a quick lesson. The 2 important things. One is you need to understand what's inductive reasoning, what's deductive reasoning, and secondly, you need to understand law of detachment that involves 2 statements only, one conditional statement, and then law of syllogism where you have 2 conditional statements. And so that's it. It's a really quick and easy unit. And I'll see you guys back in class. Bye.